So let's talk about security. What is your favorite thing about security in Solana right now?
Oh man. Delete all the code and then you won't have any bugs. I think the Rust type system is probably like what I think the strongest aspect of security on Solana. You can write really good Rust if you actually put your mind to it. There's very high level tools like traits, and the rich type system can avoid a lot of bugs, but developers do get lazy and under time constraints ship really bad code sometimes.
Yeah, I mean, we were like just like at the MEV camp, and they had like this amazing T-shirt. I'm a fight the Rust borrow checker. Damn, Rust got hands. And I think just like this really amazing meme to just like represent like the feelings towards Rust. Like I personally also like Rust is my favorite language, and I think it's really great that Solana is developing in that.
For sure. What I would like to see more though is like folks try to use like tools like Connie or Prousty and try to at least partially verify their smart contracts. I don't think you'll be able to do all of the logic, but I think you should be able to abstract a bunch of the business logic out and have that be verifiable, and then kind of treat the plumbing between the runtime and that part as a separate thing that would be a lot easier to audit.
Yeah, like I think doing like verification on like whole smart contracts at once is going to be really, really complicated, just because like Solana program model is so complicated. But just like going with individual parts makes a lot of sense. And that really forces you as well to like think about the constraints you have, like the individual functions, and just like structure it in a way that is easy to verify. Like what we've been seeing a lot is just like stuff with checks all over the place, where it's like clear they don't have like a coherent concept of where to put the checks. And I think that would really help. That's the great thing about Anchor. It just forces you to put all the checks in the beginning. There's like, I think that's actually the biggest win of Anchor. Just like someone forces you to think about every single account and put all the checks at top.
Yeah, most of the security work in a Solana smart contract is just input validation. And if you kind of like have that mindset that I have to validate every bit of input across all the accounts, you're actually like pretty far along in writing pretty good code.
Yeah. I've been looking at like runtime v2 a lot recently, and like I think there are like some really excellent changes in there. But then again, I'm also like a tiny bit scared that the type implementation of like inside Solana core is just going to be like somewhat off, or like have some minor bugs. Like what do you think about that?
So the runtime v2 is basically using a typed bytecode, which then forces a well-defined type for all the accounts and the program as well. And the really cool thing about it is that when you have a transaction and you create the virtual machine for that entire transaction, you can link all the programs together without any runtime checks. Yeah. So you can actually pass all the values because you can validate during that linking time that all the right accounts and everything else are actually being passed by the program code. That's the part that needs to be very secure. And because everyone knows it needs to be very secure, every engineer, every auditor can go look at that code. It can be fuzzed. It can have best branch coverage and stuff like that. So I think while you're kind of setting yourself up for a single point of failure, if there's a bug there, it's catastrophic. It is a very small constrained part of the code that everyone can really hyper-focus and audit.
Yeah, that's true. That's true. And I think even if you get an alternative implementation of FireDancer, also doing the type verification,
right?
Chance of critical bugs there are way lower.
Yep. Yeah. Do you think it's possible to write smart contracts with 2 implementations? This is something that I've been kind of thinking about, since for layer 1, it's obvious, right? We have a protocol. Team 1 writes, Solana Labs. Team 2 is FireDancer. Now you have redundancy. You don't have a single point of failure. Can we do that for smart contracts?
I guess we can. Like, not right now. I think you need like a wholly different smart contract language, or at least framework, for that to make sense. Like, I don't think it makes sense to write two competing contracts in Anchor. Because like maybe there's some bug in Anchor code generation, which will then be in both accounts, and Anchor forces like the same kind of structure in both. But I think that's a really interesting idea, to have like two programs which you both verify and see like the results are the same. That should be possible, and it will force developers to like really nail down how the data is structured. And that also might be like really helpful for other people also looking at the program, because you no longer have to like read the code, but there will have to be some specifications how the contract works. I like that.
I mean, this is something that the runtime could potentially support. You have like in your loader, you define program 1 and program 2, and it literally executes them both, and then makes sure that the writable accounts are exactly the same.
I mean, you wouldn't even have to do that in the runtime. You could do that right now. You could have like via CPI, just call both programs and hash the accounts pre and post.
But there's like, you have to like deal with ownership, right, of the accounts and stuff like that. It'd be kind of a...
You'd have to like duplicate state in like both contracts.
Yeah.
That's such a cool idea.
Well, if somebody's a security nerd, that would be a fun experiment to add to the runtime, is second implementation.
Yeah. So I think like, going on to like a different topic, Token 2022. I think that's also just like one of the big topics that's going to change in Solana in like the next like probably like half a year or a year.
Bugs
I don't know when it's going to
hooks.
Bugs and transfer hooks, and not even like bugs. I mean, just like the whole concept of having a transfer hook and like having fees associated to transfers, and like you're now like a pool. How do you deal with that? Like, do you just like not allow that in the pool, these tokens, or like do you allow that? Do you have like special casing there? I think that's going to be like really interesting for like some smart contract developers, and I think we have a lot of work ahead to like create documentation how to use that safely.
Yep. Yeah, I agreed. I would be very cautious if you're building, if you're allowing token 22 in your like economic activity pools, like markets or whatever, to add, the constraint checks to make sure that like you're not mixing like different assets with real value against like a user specified token 22 with all the crazy extensions enabled. Because I think the surface area there is not well reasoned yet. And be cautious. Some of those attacks you saw in Ethereum, because the ERC20 allows you to kind of re-implement whatever, and then if you have a pool and you're doing like a swap between asset A and asset B, if there's basically an on-transfer hook that can take attacks in each one of those swaps, you can probably extract value out of the LPs that way.
Yeah. The thing we've also seen is like many contracts that split their implementation up into multiple contracts. They tend to have more bugs because they now need to cross-relate ownerships of like other contracts and other accounts if they're reading that. And like transfer hook basically forces you to have a second contract because you can't recursively call.
Yep.
So that's also like going to be something I think there might be some issues.
Yep.
But overall I think it's going to be an interesting time.
Yeah.
But it's going to be secure.
Yep.
For sure. What do you think of Tiny Dancer and all of their like ways to improve like this RPC security side of things? I mean, there are gonna have to be like, I think, quite some deep changes in Solana Core as well to support all of the features you want there. How do you like approach that from like an implementation perspective?
So you can actually do a lot of this stuff today. If you submit a transaction that has like an output account that asserts the state, you can basically check that output account was finalized through like the normal bank hash. And that transaction, you imagine, is like the thing that asserts like, hey, is my balance X, Y, or Z, or like, is my smart contract at this state? So then you can get... you can construct a link of bank hashes to a bunch of votes that show that it was finalized by the quorum. that gets you like to a simple payment verification, but that solves a lot of the attack vectors where you have a corrupt RPC or something like that. What it doesn't solve is if you have a corrupt majority, like the actual quorum is corrupt and they're double signing headers and they're withholding, the data that generate the invalid header. This is where you need data availability sampling and these other tools that have been pioneered by folks like Celestia. And that is a much longer and later problem. The thing is, though, like why these attacks are possible, but they never happen. There's basically like been, 5 years of proof-of-stake networks with thousands of different networks launched of like various amounts of decentralization, literally from 20 nodes to thousands like Solana, and I can't think of a single quorum attack. And this is because any single honest node can detect a quorum attack. They don't have to be staked. And as soon as that happens, PagerDuty goes off, people's nodes shut down. It's a very short-lived attack that has basically very limited opportunity to extract value and most likely will just cause the network to halt. So there is inherent security in the system that is already preventing that. And when you kind of think of the stack, your security surface when you're signing something, you're like installed the Phantom wallet extension. So you're trusting the Google Store, you're trusting Phantom really to implement and store the seed phrase. And you're trusting Phantom to display the transaction correctly before you sign it. At that point, the additional trust of Phantom pointing to their RPC node is like very marginal.
That's
it's
true.
like even if Phantom used a light client that talked to the entire network and did all this awesome work, they could just simply display you junk in their trusted display, and you sign something, but it actually drains your whole wallet. So like fixing that RPC trust issue doesn't really fix like a security vulnerability that's often exploited today. And that's kind of like a nice to have. I think these things are going to be required when you'll see crypto really start taking over like main financial services and like be at a much larger scale than it is today, when you are dealing with a very wide variety of services that are global and you kind of don't know who to trust. But we're just really not there yet, because everyone kind of operates on some level of trust. You're trusting your wallet, you're trusting Infura or whatever, and these things are fairly stable.
Yeah, totally agree on that. Going back to these wallets, something I've been wondering for like quite some time. These wallets, most of them simulate your transaction and basically like show you the expected outcome.
Yep.
Why doesn't any wallet really implement that actually with a guard instruction at the end? Like, wallet could, for example, like if you transfer some money,
Yep.
it could just add a guard transaction at the end of the transaction that just checks maybe like 10% deviation for like some slippage fees, check are all the token balances changed as we expected. Like that won't catch all bugs, that's not compatible with all the protocols, but I think this is something like that wallets could do to really nail down a lot of these attack vectors where you just like sign a transaction that says something during simulation and then does something entirely else.
Yeah, this is something that I've talked about before, and that would be a really good improvement. But generally, like, this is only a problem if you're talking to an untrusted contract.
Yes, of
right?
course, yep.
And normally, users, most contracts are run by some kind of business that's trying to stay open and like have revenue, right? Or a protocol that's trying to like get users. And those things are persistent. So if you use Magic Eden, today, and Magic Eden's still open tomorrow, they're very, very unlikely to go and update their smart contracts to go fish all of these things in that window between simulation and execution. So this is really, I think, like a bigger problem during the bull run when a lot of stuff is launching and people are much more greedy than they're fearful, and they like just click next and everything. I think in that environment, even if you had these guard instructions, I don't even know if people would check that the wallet like showed him something. I don't even know if they would register that it showed him that everything's going to drain.
I mean, that's
the
true.
human
we
mind,
kind of like trained
right?
users to like, make it happen. Yeah. You have to be fast.
Yeah. Even if the wallet flashed, don't sign this. This is going to drain your whole thing. Confirm again. In that environment, that is, like people get greedy and they kind of like their brain switches off, I guess. I think like everyone should have the mental model of always using cold and hot storage, which basically separate your cold wallet, keep it in the ledger, only use it to do transfers, like simple transfers between the cold wallet and the hot wallet. And then your hot wallet is what you typically would use per project, a different wallet you should be using to sign things that are, less trusted on the internet. But in general, like this is like, I think, a human behavior problem more so than a technology problem. You kind of see, like, I think the Phantom folks have done a pretty good job adding security features like simulation and then guarding domains and things like that, and like using normal Web 2 kind of security to give users that feedback.
Yeah, guarding domains is probably like the more important aspect of that, to like just make sure they don't even sign stuff for like fake contracts.
But yeah, like nice thing about Solana, it literally does force the transaction to specify what state it's going to read and write. So wallets could simulate transaction and then downgrade all the write locks to read locks if they're actually not being modified, and then display only those changes to the users. You can really increase that, like, shrink that attack surface, but I'm very I'm like, I don't really believe that that's going to fix those bugs, because I'm afraid the users just are not thinking. Their brains are switched off at that point already.
I can totally follow there. Like, I've done that myself a number of times. It's just like, man, I just want to open this Word document. Like, stop with these pop-ups, go away. And like cookie banners, just like training everyone to always just click like, go away, please, don't bother me. I just want to work. Anonymity of the developers of smart contracts. Like, I think I'm an auditor, and I look at code a lot. And I audit the code, but I don't necessarily look at all dependencies. Because like in Rust, you have like this huge dependency tree, and it's really hard to look at it. And like I feel like if someone were to want to create a contract that I do not find a bug in, he would probably be able to do that. Like if somebody was like really maliciously targeting me and like kind of like see how do I like make it this, that just even the upgrader don't find it. And then you also have like contracts aren't reproducible. Or like, yeah, they are reproducible if you go for it, but like a lot of contracts currently don't go for it with like these Docker builds. So I feel like there's a lot of trust required in like the developers of the protocol itself. And like what I've been seeing is like there are some protocols which are really just like, they are there and there's a lot of money in there. And people trust the protocol because there's money in there. So
yeah,
I mean, there's already a million.
Reflexive and bad. These are like the easy red flags that people should be using to like filter out which teams are good and which are not. Are they open source? Do they have a reproducible build? Do they have like, verification would be like the next level. So like that's very hard and it requires a lot of investment, but at least unit testing and fuzzing and all this stuff every developer should be doing. And that's like, you should go through that checklist and be like, okay, this is a good team, this is what I should be using, and these are not. But like, how do you enforce that besides like?
You talk to people and like educate them, like before you put money in there, don't look at like the TVL. Do some basic like sanity checks. I don't know. It's a hard problem to solve. I think users just don't want to be doing that kind of work. I mean, you want to make money. There's money to be had. You don't like really necessarily care about these kind of things directly. But I think this is something like we should kind of like talk to users about, and like build tools that make it like kind of like easy for them to see that, like some verified flags in like an Explorer or like stuff like that. But even those are still like imperfect. So
how possible do you think it is to do analysis on the bytecode itself and do fuzzing and simulation to where you can like give some machine automated like assertions whether this code is safe or not?
We've seen some people do that, and we've attempted that ourselves as well, just like with symbolic execution of like smart contract code, looking at all the inputs. I think that's very possible for like these single instructions, where you have like this one instruction is a withdraw instruction, for example. And then you can verify that it's not possible to get like more money out of that than you have currently in your balance or something. Like these single actions, I think you can verify that. It gets really complicated as soon as you start to have like these multi-step interactions, where like first have to create an account which has like maybe some settings. And then you have like another instructions with deposits, and then you have a third instructions which maybe withdraws, and all of this state interacts with each other. And I think during like symbolic execution at least, you have like this huge state explosion, which I'm not sure you can reasonably handle. And you could probably fuzz that, but even that, you'd need to do a lot of custom work for each contract and see like how does the initialization work, and like maybe which fields I want to treat as symbolic. So in general, I think that's a too difficult problem to solve all at once, and we should focus on like more smaller problems first, if it's even possible at all. What was your favorite bug?
Oh man.
That be it smart contract or like I don't know in core or anywhere really.
Oh man. Favorite bug? This was during testnet days. I think it was the Chorus One guys that discovered it. We booted up. We were been doing all this testing on Google Cloud, and they have pretty decent network stack. And we were using 64 kilobyte frames for the shreds, and that was awesome. Performance was great. It was just we could saturate like basically the entire Google network, their internal network, with shreds and TPS. We had this chart that was like showing 250,000 TPS on like 100 nodes running inside Google Cloud. And when we booted it on like the open network to get Tour de Sol going, none of the 64 kilobyte frames arrived anywhere. Like basically, the internet just dropped them. The problem was that the way that we structured, we really optimized that loop to do verification, signature verification of the frame, and then signature verification of all the transactions inside that frame. So when we went through the step of converting that to MTU size shreds, somewhere along that like refactoring, the signature verification for the transactions was dropped. And luckily, this developer at Chorus One noticed it and created an attack vector that stole all the funds on testnet before launch. So like stuff like that, we were just blessed to have like really good folks on testnet actually finding these bugs. And yeah, he got a very well-deserved bug bounty for that.
That's a great bug.
Yeah.
Thank you, Anatoly. Thank you, Thomas.